Proof by induction of a series. Prove for all values of n that 1 plus 2 plus 3 plus all the way up to n is equal to n times n plus 1 over 2. So there's a couple of steps involved in these proofs. Proposition 1, we have to show that it's true. So on the left hand side, we have n, which is just 1. Is that equal to the right hand side? When n is equal to 1, we have 1 times 1 plus 1 over 2. 1 is equal to 1 times 2 over 2. So 1 is equal to 1. So yes, it's true. Now we assume true for n is equal to k. So we're going to get all the way up to k equals k times k plus 1 over 2. Now what we have to do now is we have to show it's true for n is equal to k plus 1. So if n is equal to k plus 1, we're adding k plus 1 and 1 onto each side. So the left hand side becomes all these numbers up to k plus k plus 1. Is that equal to n times, k times k plus 1 over 2 plus k plus 1. So what we actually have to do is we have to show that the right hand side simplifies down to be if this was k was replaced by k plus 1. So we need to show that it's going to be equal to k plus 1 times k plus 1 plus 1 over 2, which is k plus 1 times k plus 2 over 2, the whole thing over 2. So let's have a look. Does the right hand side simplify to be that? So if we imagine the first bracket is k over 2 times k plus 1, and that we have this k plus 1, and what do I multiply that by to keep it the same? 1. So from your junior cert algebra, you'll be able to see that this is going to be k over 2 plus 1 times k plus 1. And if we simplify this left hand bracket into a single fraction, we're going to get on the bottom 2, and on the top k times 1 and 2 times 1, k plus 2 times k plus 1. Is that what we're looking for? It is. It's k plus 1 times k plus 2 over 2. And just reverse it around and have it the same order. So that's equal to k plus 1 times k plus 2 over 2. And we just have to finish this off in a particular way. So we say it is true for n is equal to k plus 1. Also true for n is equal to 1. Now must be true for n is equal to 1 plus 1, which is equal to 2. And if true for n equal to 2, must be true for all values of n. It's not the only way to write the end of it, but it's just one way of saying that you've proved it true for all values of n.